Welcome to your class. Today we're going to be looking at angles of a right-angled triangle. Okay, so we're going to be given triangles and working. I remember last time we did about Pythagoras theorem. We were finding the sides of a right-angled triangle. Okay, in this case we're going to be looking at the angles of that right-angled triangle. Okay, so now the objectives of this lesson is we're going to learn a SOH CAH TOA for right-angled triangle. Okay, so this is a term we use to memorize these angles. Then the other thing is you're going to solve problems which involve angles. Okay, so we're going to be looking at these angles of a right angle triangle, and we're going to combine it with the Pythagoras theorem. Okay, so that is that. Now let's get into our lecture, and make sure you subscribe so that you don't miss when you are going to look at different exam questions on this Pythagoras theorem and SOH CAH TOA. That is that. Let's get into it. Okay, now let's take a look at angles of a right angle triangle. Okay, so before we get in, let's understand our right angle triangle. This is our right angle triangle here. Just assume that these lines are straight here. Okay, so this is a 90 degrees. This is the meaning of right angle triangle. It is a 90 degrees here. Okay, so let's say this side is A, and this is B, and this is C. Okay, so I'm going to name this side. Okay, so let's say this is our angle. We are using this side. In this case, let's say it's theta. Okay, so when you put this angle on this right side, okay, on this right side bottom, okay, you name your triangle that this one becomes the adjacent. Okay, okay, when you put this angle this side to the right, this one becomes the adjacent, and this one becomes the opposite, and this one becomes the hypotenuse. Okay, so make sure you remember that. You remember to name this side. Okay, so this can be represented by A, this O, and this H. Okay, so the other thing you have to remember that all angles, this angle and this angle, let's say this angle is alpha, this is theta, this is alpha. Okay, so all angles add up, to 180. Okay, 180 degrees. Okay, so you have to remember this for all triangles, not only right angle triangle. For all triangles, all angles add up to 180 degrees. Okay, so now from this, okay, so there is this ratio what we call sine theta. Okay, so the sine of this angle. Okay, and there is a ratio what we call cos theta. Okay, if you can look at your calculator, you can see that there is this what is called sine, and this is called cos. Okay, then and there's the other thing which you call tan theta. Okay, so these are the ratios of this triangle. Okay, it's just a ratio for this to this and this to this. Okay, so I'm going to be giving up this ratio. Okay, so sine theta, okay, this ratio, okay, is just a number. This ratio is represented by saying that opposite of hypotenuse. Okay, so if you say this opposite of hypotenuse, okay, so this is what we call sine theta. Okay, so what you do is you just write the angle here and include the opposite and the hypotenuse and use the calculator to work out this solution. It's very easy. I will show you how to do it. Then the other ratio is cos theta is equals to adjacent over hypotenuse. Okay, so this adjacent over hypotenuse is the cos of this angle. Then the other thing is tan theta is the opposite over the adjacent. Okay, so this is it. This is it on this. Okay, so this, if you take this opposite and divide with this, it gives you tan of this angle. Okay, so this is the ratio you have to remember. Okay, so the easy way to remember them, you can just say SOH CAH TOA. Okay, so SOH CAH TOA. Okay, so you can remember this word as SOH CAH TOA. Okay, so in this case, you're going to say sine is equals to opposite of hypotenuse. Okay, then cos is equals to adjacent over hypotenuse. Then tan is equals to opposite over adjacent. Okay, so this is the way you can remember this very easily. Okay, so that was that. Now let's take an example where we apply this. Okay, so this is very easy. For right angle triangle, remember that all angles add up to 180. And if you want to find the angles given the length of this side, okay, the length of these sides, okay, you can just say opposite of hypotenuse, adjacent of hypotenuse. Okay, so as easy as that. Now let's take a look at an example. Okay, this is our example here. I'm going to be solving to find y and x. Okay, so I'm going to be using this angle to find it. Okay, so this is it. Now let's take a look at how do we solve it. Okay, so the first thing I'm going to use this angle. Okay, so here we can see that this angle is to our right. Okay, so we can name this one adjacent, and this angle we can name it opposite, and this long line we can name it hypotenuse. Okay, so this is the first thing you have to do. Okay, so we have here we are given our adjacent. Our adjacent is here, and we are given our angle. Okay, so our theta is here. Okay, so we just have to find a relationship where we can use adjacent, hypotenuse, and opposite, and the angle to find the other. Okay, so let's write our term SOH CAH TOA. Okay, so in this case, we're going to see that sine doesn't work because we don't have an opposite. Okay, we don't have an opposite in the hypotenuse. It doesn't work. Then here we can see that cos can work because here we will see that we have our adjacent. Our adjacent is given. Our hypotenuse is not given, and our angle is given. Okay, so this one can work because we have our angle and we have our adjacent, and we don't have only hypotenuse. Okay, so we want to find this hypotenuse. Okay, so what we do here, we're going to take cos 45. Okay, cos 45. Okay, and say it's equals to cos 45. I remember I said that cos theta is equals to adjacent over hypotenuse. Okay, so in this case our adjacent is 6. Okay, so cos 45 is equals to 6 over, then here we can say that our hypotenuse is y. Okay, so our duty is to find this y. Okay, so how do we do that? We are going to say we're going to multiply both sides by y, so this y cancels this, so it becomes 6 is equals to y cos 45. Okay, then after that, we're going to divide the both sides is cos 45, cos 45. In this case, we're going to get y is equals to 6 over cos 45. Okay, so now we are going to use our calculator. You can see that our y is equals to 6 root 2. Okay, so this is it. You can punch it on calculator, or you can use any way you want, but you can use those tables, or you can just use the calculator. Okay, so you can see that our y is equals to 6 root 2. Okay, so now our duty is to find x. Okay, so we know that our y is equals to 6 root 2. Okay, so now we're going to be using Pythagoras theorem to find this opposite. Okay, so we can use the tricks again to find it, but I'm going to just use Pythagoras so that you can memorize it. Okay, so Pythagoras here, we're going to say this side is our, we're going to name A, B, C first. After that, you're going to say this is our A, and this is our B, and this is our C. Okay, so we're going to say C squared is equals to A squared plus B squared. Okay, so our C squared in this case is a 6 root 2. Okay, so it's 6 root 2 squared is equals to A squared is 6 squared plus B squared. Okay, so B squared is what we want to find. Okay, so we're going to say B squared, we're going to put B squared in this side, then we're going to say 6 root 2 squared minus 6 squared. Okay, so in this case, you can see that here we're going to get our answer B squared, as in this case, we're going to find that it's 72. Use your calculator. If you can't multiply it by head, then here we're going to see that 6 squared is 36. Okay, so in this case, we're going to see that B squared is equals to 36. And after that, we're going to put a root this side and I put a root this side. Okay, so we're going to find that our B is 6. Okay, so this is how we can use Pythagoras theorem and trig ratios. Okay, so now we can see that x is equals to 6 and y is equals to 6 root 2 and this one. Okay, so you can choose to use decimals here. You are going to see that our answer here is going to become 8.49 centimeters. Okay, and in this case it's going to become 6 centimeters. Okay, so that was that on this trig ratio and Pythagoras theorem. Make sure you grab it. If you have any questions, please feel free to ask in the comment section, but make sure you subscribe.